So for the vertical shifting, we're going to just be adding some number outside of the function, right? So we already know what the basic graph of sine and cosine are, right? And now we're just going to add c to the outside, right? Outside the function. And that's going to shift it up and down. You already know that, right? So if you look at exercise 1, here's our graph of sine, right? Sine always like starts down there at the origin, right? Cosine starts up here, but sine starts down here, right? And it does this periodic wavy thing. And it always goes between 1 and -1, right? If it's just a regular basic sine curve. And what I would have you notice, right, since it goes between 1 and -1, good gravy, could you consider this thing here a midline, right? And it goes up and down equally above and below that midline, right? So let's take a look now at the function sine of x plus 3. So what would that do to this graph that's currently on there? What would you say?
It would shift it up 3.
It's going to shift it up 3. And in part B, they want us to graph that. Well, and this is a real easy way to avoid confusion, right? So the graph shifts up 3, the midline's going to shift up 3, right? From the original. So right now our midline is there at 0. So let's just go up 1, 2, 3 and put that in there. And we can kind of just now pretend that's our x-axis, right? And we're going to go from -2 pi, -360, to 2 pi, 360, all right? So basically, we just copy the same curve, right? We're going to point here, here, there. And it's probably a good idea to put these points in here before you start so you don't accidentally go through the wrong thing, right? Wait, something didn't work out. What happened there? What did I do? Oh, I know what I did. Duh. See, I did it. Wait a minute. I missed this one here. There we go. Thought something looked odd there. That, there, and there. And then we just take the thing and draw a nice smooth curve, right? No V's. Nice smooth humps there. You get better at that with practice. And there you go. So that's y equals sine of x plus 3. We'll go ahead and label it. Y equals sine of x plus 3 on the outside. All right, everybody good with that? Okay. Let's go down to exercise 2. Now we have cosine. We're doing something a little bit different now, right? So we know what the graph. Let me go ahead and put just a regular cosine x graph in there, right? That one starts like right here, right? And then go down like this, just putting without any shifting cosine in here, like that. And then we can, or do midline, right? So this would be the original without any shifting to it. All right. Okay. All right, so the plus 1 is going to lift our midline up 1, right? Everybody agree with that? I'll do a different color. So let's put that midline up 1, like that. But we've got one other thing here to consider. We're doubling it, aren't we? So what do you think multiplying by 2 will do to this function, guys?
It would affect the depth.
Right. Well, if you remember yesterday, we called that the amplitude.
Yeah,
right?
amplitude, like the volume.
So if we're multiplying the function by 2, if we're thinking of this cosine curve modeling a sound wave, from a speaker, right? Multiplying by 2 is like taking the volume knob on the speaker and turning it up, right? So it'll get taller. It's going to move up 1, right? You all agree? Give an equation of the horizontal. Okay, so they want an equation of the horizontal line that this curve rises and falls 2 units above. I don't know why they want 2 units above. I think they want this green line here, right? What would be the equation of that green midline I just drew in there?
Cosine, the cosine of x.
No, just the green, the horizontal green line. What axis does it cut through?
Oh, it cuts through the.
Which axis does it cut through, that green line?
Oh, the y-axis.
So it's y equals, and where does it cut through the y-axis at?
0.
The green line?
Yeah. One.
Not 0.
Oh, 1, sorry.
1, right? We shifted it up 1. The regular cosine would be at 0, right? All right, now they want the range of this. Okay, range would be the y, like between what y values. Well, right now, what is the range? It goes from what to what? Without shifting it, what is the range?
The range is 1 or -1.
Goes between -1 and 1, right? Let me get rid of that thing. So cosine x, right, without any shifting, and I'll do this. We'll use the interval notation from -1 to 1, including, right? I'm using the hard brackets. But what about 2 cosine x plus 1? Maybe we should graph that first, okay? So we're shifting it up 1, okay? Different color. So we're going to start up here. I always like to start here. Oh, wait a minute. We're multiplying by 2, though, aren't we? So instead of starting here, where am I actually going to be starting?
You'll be starting in the...
One up above that, right? Normally it would be here, but now we're going to start here, right? And it's going to go down here, so it's going to be 2 above and below the midline. The amplitude, right? It's changing, okay? And so we'll end up like down 2 below, right? Good that, right? And then there. Get that right. Oh, I lost my... Got too many lines in there. That's the parallel here, right? Let me make sure I got it. So here, down here, here, back up to the midline. There we go. I got all those lines dancing on my face. And we'll go over this side, back to it, right? And the next one over will be 2 below, right? 2 below the midline, not the y, right? Not the x-axis. Okay, and then here, and then there. I think I got it right now. All right, so let's sketch this in here. Oops, stop writing. Here. Okay, so what do you notice? This graph shifted up 1, and then we doubled the amplitude, right? So here would be our y equals 2 cosine x plus 1. So now, what would be the new range? This goes up and down between what values? What's the lowest value it hits?
-1.
Like you can see from the graph, it's -1. And what's the highest value of the green graph? 3. Goes from negative, so it oscillates between -1 and 3. Okay? So you get the idea that the plus or minus out here shifts it up and down. And if you're multiplying that guy, right, that makes it, well, taller. It turns up the amplitude, makes the humps bigger. Okay? Any questions so far? Okay. That's all we really need from this section. We were going to, let me make sure. Let's at least do one more of these, I think. They want the range of this, but let's just go ahead and graph this. 4 sine x minus 2. Let's just put sine in here, right? Let's put y equals sine x so we have something to go by. And we know that, you know, that's going to be the midline of the original function, right? So sine starts here, like that. Okay. And we come back the other way, right? Let's put sine in. I'd like to put this in because it'll help us see what we're going to do. All right, so if we do 4x minus 2, what does that do to our sine graph?
Value 2 will shift it down 2.
It's going to shift our midline down 2. So let's put that in there. And that'll be helpful to see where it starts, right? And what is the multiplying by 4 going to do?
It will multiply the amplify. It will amplify it by 4.
Yeah, so Like if we start here, instead of going up 1 to get here, we're going to go up how far?
It'll go up by 4.
So 1, 2, 3, there, right? Okay. So where was our midline? Okay, I'm losing track of myself. Okay, and then back down to here, right? And then 1, 2, 3, like that from the midline, and then back up to here, like that. And then we're down here, 4, right? Back up to the midline, then up 1, 2, 3, 4 to there, right? And then it'll just, because the graph stops there, right? So let's sketch this out here. I'm being a little sloppy, sorry. Yeah.
I think you did the -2 pi.
What do I do? Shifted it down
You
to?
didn't put it on the, it's supposed to be down to.
Yeah, that's where our midline is. Yep, right here.
Yeah, -2 pi.
Oh, well, no. See, it would keep on going. It's just the
Oh,
graph.
okay,
Yeah. I can see where you got that. I see where you're at now. No, so the graph starts there, right?
Oh, okay.
I think. No, you know what? No, you're right. You got me. Hang on. This would actually, yeah. It could be a little tricky, even if you've done this a few times. It would actually come right back down here, wouldn't it? I'm sorry. Yeah. You got me, Antonio. All right, so here is y equals 4 sine of x minus 2. So I would say the first thing you should do, if you have something tacked onto the end right there, go ahead and sketch in your new midline. Because as you can see, you know, I had the other graph on there, and your eyes can dance around a little bit. It's probably easier to see if I didn't have the original blue sine x in there. We probably wouldn't have made that mistake, but is there anybody has a question? Is anybody a little confused here? We can straighten it out now. Anybody? Ask now, because, you know, test is tomorrow. Okay. Well, your problem set for this, it's not going to be too, we're going to skip this stuff here. We're going to skip all of this. We're going to skip that guy. And we're just going to go problem set will be just number 1 only. Okay? Number 1 only. Let's stop this video. Save it.